Hello everyone. In this video, I will be showing you how to set up an Android OS in VirtualBox. Firstly, you need to download the ISO image following the main website and see if it's stored. Now we'll create a virtual machine. We'll name it VM01. We'll select the ISO image that we've just installed. We'll change the subtype to either Linux, and you'll see it's in 64-bit. Now we'll set the base memory to 4 GB, and the processors, we'll set it to 2. However, if your host machine supports it, you can add more. Then we can set the storage to 32 GB and click finish. Before we start, we'll need to check the settings. A couple of changes need to be made. Firstly, the pointing device, we need to change it to a USB tablet. We'll need to max out our video memory, and we also have to change our controllers to VBox SVGA. We'll ignore the error message shown at the bottom. You can either select net or bridge adapter for your network. For simplicity, we'll just select net, and then we can click OK and start the virtual machine. Now you'll see that there are two options that we can use: auto installation and manual installation. I will show the manual installation. Just by watching that, you can do the auto installation. Now, since there's no partitions that we can choose, we need to create one using cfdisk. Now we can proceed to select the partition. Select ext4 and then proceed to format. Now, before we are able to reboot the system, we need to force the unmount, removing the disk. This is to ensure that the VM is installed correctly, prevent a repeated process of installation. We need to ensure that we have connection to the internet. So we'll see virtual Wi-Fi network that we can connect to. So here I will sign into a Google account to verify that we have internet access, and we'll also use this account to download the apps from Google Play Store.
So once the setup is finished, we'll go ahead and open settings. Now, since the Android VM lacks a device care feature, we will open to test battery, memory, storage, performance, and security separately. Now once we open up battery, you can see it's 100%. The battery saver is turned off since there's no actual drainage. And we've just started the VM. Now you'll see that the Android VM and the host has the same battery percentage, but you'll see in another scenario that the Android VM's battery percentage matches the host when it started. However, when the host machine has drainage, the Android VM's battery percentage stays the same. Now let's take a look at storage. You'll notice that there is 35.6 GB used out of the 64. Remember that we assigned 32 GB. Now this is probably. Now let's take a look at the security features. You see the Google Play Protect is enabled. Device update is slightly outdated. We have Find My Device enabled as well, and some other features. Also notice that there's only one device admin app. And we also have Android safe browsing. So we've scrolled to the end of settings, and we are yet to find a feature that we can use to check for the memory and performance. So we need to enable developer mode by tapping on the build number a couple of times. So now we can see that 1.4 GB out of the 4 GB that was allocated has been used, and this is indicating a normal performance, and this is expected because we've just started the VM. We haven't really opened any other apps besides the settings. So let's go ahead and open running services. Now here we're able to see how much of the CPU has been used by the apps in the system. We can also see the processes running in the background. We'll have to take note of the values shown on the top right for comparison. Now we will simulate downloading an app such as Clash of Clans just to show the impact it has on performance. So Clash of Clans could not open, so we'll try downloading another app, Temple Run, just to see if it runs. So this error message says that it failed to load the necessary libraries to translate the ARM code. These libraries are not included by default in the ISO, which is why Clash of Clans and Temple Run could not run. So you'll see even by enabling the native bridge, it still does not allow. So we'll have to download an app that uses native libraries, and Cut the Rope is one of them. As you can see, it runs, opens, and we're able to play the game. Now, you'll see the changes in the storage. There's a slight increase. Go ahead and open developer mode. See the changes in memory. As you can see, there's a slight increase. You'll also notice in running services that the values on the top right have slightly increased, showing how much of an impact Cut the Rope has on the CPU. To optimize the user experience with the virtual machine, we can allocate more RAM, increasing it from 4 GB to 6 GB. That's only if your host machine supports it. Also, clear the cache directly from the application, removing temporary app data. We can also clear cache in the storage setting by using the free up space. We can also close unused apps to release memory and maintain normal performance.
That was the demonstration.
Thank you for watching.